Hi, welcome to the next homework video. So for this video, we're going to be doing homework 7. So homework 7. Okay, so for homework 7, there were problems in 5.7.3.1. And so for number 1, let x be a standard normal random variable. Okay, so x is a standard normal random variable. We want to find the probability that x will take on a value that is the following. So for part A, we want to find the probability that x will take on a value less than 1.5. Okay, so for the table that I provided to you, right? So for the table, it gives you probabilities that a standard normal random variable. This is a standard normal random variable. So it gives you these probabilities. So for x, which is a standard normal random variable like z, this is the probability that x is less than or equal to 0, plus the probability that 0 is less than x less than 1.5. And so this probability is 0.5 or half, plus this probability. And so by the table, if you go to 1.5 and then 0, the table will say that this probability is 0.4332. And so now in total, this is 0.9332. And so that's part A of number 1. Okay? So for part B, it says find the probability that x is greater than 2.14. Okay? So the probability that x is greater than 2.14 is 1 minus the probability that x is less than or equal to 2.14. Right? So that's equal to 1 minus the probability that x is less than or equal to 0, plus the probability that 0 is less than x less than 2.14. And I put less than or equal to here, but I'm just going to switch it to less than because those probabilities are the same. Right? It doesn't matter if you have the equal sign or less than or equal to or less than up there. It's the same. Okay, so this is 1 minus that probability, which is 0.5. Plus this probability, which by the table, 2.14 is 0.4838. So 1 minus 0.5 plus 0.4838 is 1 minus 0.9838, which is equal to 0.0162. So the probability that x is greater than 2.14 is equal to 0.0162. So that's 1AB. So for C, sorry. Okay, so I need to get my eraser. So for C, the probability that x is between 1.5 and 2.14. Okay, so what's the probability that x is between 1.5 and 2.14? Well, that's equal to the probability that x is less than 2.14 minus the probability that x is less or equal to 1.5. Okay? Okay, and so we found this, so you can use part A and part B and you can just subtract these two, right? So I erased it. So so the probability that x is less than or equal to 1.5 very quickly is the probability that x is less than 1.5, which is the probability that x is less than or equal to 0, plus the probability that 0 is less than x less than 1.5. And it's equal to 0.5 plus 1.5, 0.4332, which is 0.9332. Right? So this is minus 0.9332, and the probability that x is less than 2.4 is equal to the probability that x is less than or equal to 0 plus the probability that 0 is less than x less than 2.4, which is 0.5 plus 2.14, 2.14, 0.4838. It's 0.9838. And so probably x is less than 2.14 is 0.9838. 0.9838 minus 0.332 is equal to 0.0506. And so that's the probability x is between 1.5 and 2.14, 0.0506. Okay, so that's part C. And then part D, the probability is x is less than negative 1.32. So probably x is less than negative 1.32. Well, that's 1 minus the probability that x is greater than or equal to negative 1.32. And so this is 1 minus the probability that x is greater than or equal to 0, plus the probability that negative 1.32 is less than x less than 0. Because then and so this is equal to 1 minus the probability that x is greater than or equal to 0 plus the probability. Now, because of symmetry, I can say this is probably the same as 0 less than x less than 1.32. And so then this is equal to 1 minus probability of that is 0.5 plus the probability of this by the table 1.3 and then 0.2, 1.32, 0.4066. Okay? And so this is 1 minus 0.9066. And so that's equal to 0.0934. And so the probability x is less than negative 1.32 is 0.0934. Okay, and so that's part D of number 1. Okay, so let's look at number 2. Okay, so number 2 is x is a standard normal random variable, and we want to find z, right? And so we want to find z if the probability that x will take on a value less than z. So the probability that x will take on a value less than z is equal to 0.9842. Okay, so you kind of have to, you have this long table of over 300 numbers. You kind of have to go fishing for the right number. Now, okay, so now this might seem silly, but okay, so I see it. So, so the probability that x is less than z is equal to 0.9842. And so I'm going to assume z is positive, okay? So assume z is positive, okay? So then the probability that x is less than z, where z is a positive number, is the probability that x is less or equal to 0, plus the probability that 0 is less than x less than z. And so the probability that x is less than or equal to 0 is 0.5, and that's going to be plus the probability that 0 is less than x less than z. Make sense? Now this is going to equal that probability which is given is 0.9842. So 0.5 plus that probability is 0.9842, and so that means therefore that the probability of 0 less than x less than z is equal to 0.9842 minus 0.5, which is 0.4842. And so now let's look in the table. Is there a probability of those over 300 numbers where the probability is 0.4842? And there is. If you look at z equals 2.15, if little z is 2.15, then the probability in the table tells you that it's 0.4842. So the table says that when you find the right number, that the probability that 0 is less than x less than 2.15, you're basing this on the table because you can't compute the integral, you have to go by this table. 2.15. Probability that x is strictly between 0 and 2.15 is 0.4842, which is exactly that probability. And so, that means the answer is z. We found z. Z is 2.15. Okay? So we weren't looking for the probability 0.9842. We were looking for 0.9842 minus 0.5, which is 0.4842. Because if z is positive, then that's the probability left, and then that has to be 0.4842, and that's if z is positive. If z was negative, we'd need to look at things differently. So z was either positive. If z was 0, the probability would have to be 0.5. So you know z is not 0. So z is either positive or negative, and so it's like a coin flip whether or not z is positive or negative. There's one answer, and so I went kind of the more, I assumed, okay, maybe z is positive, right? And oh wait, actually, this probability is more than a half. It's 0.9842. So if z was negative, this probability would have to be less than half. So if you're finding a z like this, where it's less than 0.5, z would be negative. If this is larger than a half, then z is positive. If this was exactly 0.5, z is 0. So the fact that this is 0.9842, almost 1, it's obvious that z has to be positive. And so then you find that you have to find this probability that equals 0.4842. And you get z equals 2.15. Okay, so let's do another one. Now let's do, and this is when x is less than that z, right? Okay, so you have to use the fact that the probability of x being less than or equal to 0 is 0.5, and the probability that x is greater than or equal to 0 is 0.5, right? When you have an x as a standard normal random variable. So for 2 parts, let's do part B. Probability for B, it says probability that x is greater than z is equal to 0.3085. But now x is greater than z. And so now if you're looking at the number line, and here's 0, and you want to find the probability that x is greater than z. If z was here, you'd have more than a half probably. So z is going to have to be positive again. But now the probability that x is greater than z, that probability is going to have to be 0.3085, where z is positive. So here, assume z is positive, and so it's not a guess. We can tell from the probability that z has to be positive. And so now, I'm going to switch it, and so we'll see why. So the probability that x is greater than z, little z, is going to equal 1 minus the probability that x is less or equal to little z. This is going to be equal to 1 minus the probability that x is less or equal to 0, plus the probability of 0 less than x less than that z. Okay? So this probability, which is 0.5, plus that probability. Right? Okay, this is going to be 0.5 here. and then this thing is going to be the thing, the question mark, the thing we don't know. But the thing we're going to try and find. We're going to find that, and then we should get, okay? So this is 1 minus 0.5 plus that probability, which you can find on the table. And so this is going to be 1 minus 0.5, which is 0.5, minus probability of 0 less than x less than z. And so that is, the probability that x is greater than z is equal to 0.3085. So 0.3085 is equal to 0.5 minus that probability. And so that means that the probability then of 0 less than x less than z by algebra is going to be 0.5 minus 0.3085. And that what that's going to be equal to is 0.1915. Okay? And so now we want to find in the table a value of little z where the probability of 0 less than x less than z is equal to 0.1915. So you want to find the number 0.1915. And so you can tell that the numbers, you know, they kind of get larger as you go to the bottom right and get smaller as you go to the top left. So when you see 0.1915, you're seeing that those numbers are kind of like near the top left. And you can see the number 0.1915 at the top, near the top left, at z equals 0.5. So the probability that 0 is less than x less than z, here you get the value 0.1915 when that little z is equal to 0.5. So here I'm going to put 0.5. That probability is 0.1915. And so that means z, we're trying to find z, that z is going to be 0.5. And so for 2b, the answer is z equals 0.5. Okay, so that's part B. Let's do part C. Okay, so part C. Okay, so for part C, we're going to find z, where the probability that x is greater than z is equal to 0.5675. Okay, so the probability that x is greater than z is equal to 0.5675, and it's also equal to 1 minus the probability that x is less or equal to little z. Well, that's equal to 1 minus the probability that x is less than or equal to 0, plus the probability that 0 is less than x less than z. Now, it could be less or equal to z. I can get rid of the equals, less than or equals to, and put less than, because the probability is the same. Because the probability that x equals z is 0. So 1 minus the probability of x less than or equal to 0 is 0.5 plus that probability. Okay? And so that's equal to 1 minus 0.5, which is 0.5, minus that probability, minus the probability of 0 is less than x less than z. So 0.5675 is equal to 0.5 minus that probability. And so the probability then that 0 is less than x less than z, that implies that that probability is oh, okay, wait, so the probability that x is greater than z is 0.56. So here's 0. And so if x is greater than z, and z has to be negative. So here, assume z is negative. So the probability that x is greater than z is going to be, it's going to be, so this is equal to 0.5675. And this is equal to the probability that x is greater or equal to 0 plus, that's that probability, plus this probability. And so that's for the probability that z is less than x less than 0. Z is negative. And so that's equal to 0.5 plus, now due to symmetry, this thing is the same as the probability of 0 less than x less than negative z. Okay? Okay? negative z because you switch it, so this becomes negative z here. So that implies that now this probability, so the probability of 0 less than x less than negative z is equal to 0.5675 minus 0.5. And that's equal to 0.0675. So you find the table where you get 0.0675. And so what you see is 0.068. And so that's the one we're going to use. That's the closest one. So you get 0.068. So when z is, so the probability that 0 is less than x, less than, I'll call it z prime just because it's not that z, is equal to, oh no, it's less than, I'm going to give the number. It's 0.17. Is equal to 0.068. Okay, that's very close to 0.0675, and so we're going to estimate and say that that number should be 0.17. So what should be 0.17? Negative z. So what we concluded is that negative z is 0.17. So that means z is equal to negative 0.17. And so that's the answer for part C. Z is negative 0.17. Okay? So we'll stop there, and so those are the answers to problems in homework set. See you next time.